Okay, so now we know that by using, for example, the keyword extends, we can create two objects and make the second, we can create two classes and make the second classes to inherit the properties like the data or methods of the first class, right? Here I want to show you that when we have two classes, the second class can have the second class, which is, for example, here the subclass, we have the subclass and the superclass, right? In superclass, we have so many methods, and subclass inherits all of those methods. So in subclass, we can define a method with the same signature as the method that we already have in superclass. And it is called, here, this is called method overriding, right? And when we create an object of the first class, the superclass, and we call, for example, that method, if we call it, for example, method X, then the method inside the superclass would be invoked. And if we create an object from the subclass, then the method inside the subclass would be invoked if we call that method. So here there is one simple example. So we have two classes, shape and rectangle. Rectangle is a class that inherits from shape, right? So we have a method, for example, draw inside the shape. The point here is that we can define a method with the same signature as draw in class rectangle, and then by creating an object from this class, we can call the method, this method, the draw method that is already exists inside the class rectangle. So here you see rectangle R equals new rectangle, right? We are creating one object. Then R dot draw. Here we are calling this method. Here the method inside the class rectangle is invoked, right? Another point is that we can call the methods inside the superclass by using the super word inside the methods of the subclass. For example, here draw is a method inside the rectangle class, and by using super.draw, we are actually invoking the draw method that is inside the superclass, inside the class shape, right? So this is what is called method overriding. Okay, so now you are familiar with inheritance. You know that in inheritance we have actually two classes. The first class is the superclass and the second class is subclass. Superclass is the class that consists data and methods, and subclass is that class that inherits data and methods from superclass. So actually, superclasses are more general and subclasses are more specific. There is another type of class in Java that can be, mm, you know, specified by the modifier abstract. These type of classes that are called abstract classes are actually a place for common data and common behaviors of subclasses. So when you create an abstract class, you actually doesn't create an object from that class. So for example, if you create an abstract class with the name shape, like what we have here, public abstract class shape, this class is abstract. It means it contains common data and common behaviors for subclasses. And since this class is abstract, you cannot create an object from this class. So if you write shape S equals new shape, as you see in this slide, so it would be illegal and it doesn't make sense at all. And the reason is that abstract classes, it doesn't make sense to create an object from them. So that's about abstract classes. We also can have methods that are abstract as well. So actually an abstract method is a method signature without a definition. So it doesn't have any definition. It has just signature. And another important point about abstract methods is that they are just inside the abstract classes. So you cannot have abstract methods inside other type of classes. So abstract methods are just created inside abstract classes. And the main purpose for this type of methods is to be overridden in derived classes with the same signature. Okay? For example, we have a very simple example here. Shape is an abstract class, and inside this abstract class, we have an abstract method. This method, the name of this method, as you see here, is find area. So public abstract double find area. As you see here, we just have the signature of this method. We don't have any definition for this method, right? So now you are familiar with inheritance, with the concept of inheritance. So it's good to know that in Java programming language, every class is derived automatically from a class which is called object. So if there is no inheritance for a class, then that class is the subclass of the object class. And you need to know that in this class, in the object class, there are several methods that 3 of them are very important, and I've mentioned them here. So actually, by knowing that, you will recognize that all of the classes in Java will inherit these 3 methods. The first one is public boolean equals. The second one is public string to string, and the third one is public object clone, right? And I'm going to explain each of these methods in more details in the next slides. So the first method is public boolean equals, right? So the goal of this method is checking the equality of 2 objects. So the format for using this method is, as you see here, object1 dot equals object2, the name of the second object inside the parentheses, right? You also can implement this method in another way, as you see here, public boolean equals, then return this equals if equal operator object, right? So this implementation is actually the same as, it is actually equivalent to the equals operator, right? And the reason is that it only tests the reference variables for equality. So another method is to string. This method, the actually functionality of this method is returning a string that represents the object. So in order to use this method, you need to follow this format, object name dot to string. So the default version for this method is, as you see here, public string to string, and then return numerator plus slash plus the numerator, right? So that's the default version for the method to string. So as I mentioned before, all of the classes in Java inherits from object, right? And this object has already 3 methods, and one of these methods is toString, right? So actually, all of the classes in Java already have this method, right? So we can say that this can be overridden in any derived class. So if you want, for example, to use this method for a class, for example, a class with the name fraction, first we create an object for this class, as you see in this example. Fraction f1 equals new fraction. So now we have an object of the class fraction, and then we can call the method toString that is already inside this class, right? So f1 dot toString will call the method toString. So it's good to know that If you write just F1, it also prints that string because it also invokes the toString method, right? Here you can see two simple examples that can show you how equals and toString methods work for a very simple class named fraction. So you can follow these links and see these examples. Okay, now let's see how we can use these three methods in a simple example. So in this example, we have a class, right? And the name of this class is fraction. So that's a class with two variables, numerator and denominator, right? So both of them are private. So private int numerator, we declare this and initialize it to be 0. Then private int denominator equals 1, right? Then we have two constructors for this class. The first one has no parameter, so public fraction, and the second one has two parameters, so it receives two parameters as input, and then it will use a method, so public fraction int n and int d. So if set n and d is false, then set it as 0 and 1. We will have one method. This method, the name of this method is set, so public boolean set int n int d. If d is greater than 0, then let the numerator be n, denominator be d, and then return true. Right? So that's if d is greater than 0, else return false. We have another method. This method is The name of this method is show public void show system.out.print numerator plus denominator. Public int get numerator is another method that is going to return the numerator. So return numerator public int get denominator that is going to return the denominator public double decimal that is going to return the double version of numerator by denominator. So return double numerator denominator. Okay, now let's check the method equals and toString for this simple class. So first let's create some objects from this class. So fraction f1 be new fraction fraction f2 be new fraction, for example 3 and 8. Fraction f3 be, for example, new fraction 3 and 8. First, let's check the equals method for this simple class. So if you remember, the equal method checks the equality of two objects, right? So here, what we are going to check, we want to check whether, for example, object f1 is equal to object f2 or not, whether they are equal or not. So then we are going to print the result. So system dot out dot print ln, for example, f1 dot equals f2 returns f1 dot equals f2, right? So here we have checked the equality of f1 and f2. Then we want to check the equality of f2 and f3. So system dot out dot println, so f2 dot equals f3 returns f2 dot equals f3, right? So let's see what is the result. Well, as you see, f1 here is, since f1 and f2 are not equal, right? But f2 and f3 are equal. So let's see what is the result. So as you see, the result for these two are false because they are totally separate objects, right? So for example, if we want to check the equality, for example, f2 equals f2, you see the result here is true. Okay, let's see how toString works. The system dot out dot println, sorry, so it's f1 dot toString returns f1 dot toString. Okay, so let's see system dot out dot println f2 dot toString returns f2 dot toString. So if we see the result, you can see that we see F1 and F2 as strings, right? So let's see system dot out dot println F2 is you can see the value of F2 here. So that's a very simple example to show you how these methods equals and toString works for a very simple class. So in the previous example, we had this simple class fraction, right? So here I want to actually use the default implementation of equals and toString. So for example, equals public boolean equals so fraction f, and here we are going to check whether numerator and denominators are equal or not. So if numerator equals f dot numerator and denominator equal f dot denominator, we are going to return true. Else, we are going to return false. And for toString method, public string toString return numerator denominator, right? So these two are actually two methods to default implementations of these two methods equals and toString. So let's see how these two now works for our object, right? So as you see, f1 equals f2 returns false, f2 equals f3 returns true, right? And for toString, that's the same. As you see, the Default implementation has been called in this part, right? f1.toString and f2.toString. So we also have one method in order to make copies of objects. If you do the direct assignment between object names, then that will only copy one reference variable to another. So you need to use the method clone in order to make copies of objects. So new object equals SomeObject.clone. You need to keep in mind that not all of the objects can be cloned, and only objects that are implementing the java.lang.clonable interface can use the clone method. Here also you can see some methods from class object and a very brief description for each method. I hope that it helps.